Hello everyone, myself Apurva, and today the topic of my video assignment is Introduction to Constraints in SQL and the Introduction to Query Retrieval Techniques. So first let us know what are the different constraints and what are constraints in SQL. When designing a database, understanding the various types of constraints is crucial. Constraints define the rules that data in a database must follow. From ensuring data integrity to implementing business rules, constraints play a vital role in SQL databases. In SQL, that is structured query language, constraints are rules and restrictions applied to tables and columns to maintain the integrity, accuracy, and consistency of data within a database. Constraints help ensure that the data stored in a database follows certain guidelines, preventing inconsistencies and errors. There are several types of constraints in SQL, each serving for a specific purpose. Now, there are different types of constraints which can be used in SQL. The first one is the primary key. A primary key is a unique identifier for a record in a table. It ensures that each row in a table is uniquely identified by a specific column or combination of columns. Primary keys cannot be null, and for the implementation, primary key constraints are implemented when designing the database schema. They are often used to establish the relationship between two tables. In a database schema, a primary key is basically denoted by underlining it. Now, for in the below schema, we can see that the student ID is underlined. So the student ID is a primary key as it is a unique ID in that table. Next, we have the foreign key. Establishes a relationship between two tables by linking a column in one table to the primary key of another table. Ensures referential integrity, meaning that values in the foreign key column must exist in the referenced table's primary key column. Foreign key constraints enforce referential integrity by ensuring that a value in one table exists as a primary key in another table. Foreign key constraints do not have to be unique, allowing multiple rows in the referencing table to refer to the same row in the referenced table. Now, when we take two tables over here, book and copies, here we can see that book ID is present in both the tables, and book ID is a primary key of the table book. So basically, as the definition of the foreign key states that it gives a linking between two tables, that is in this case it is book and copies, and the it will link the book ID, that will be the normal attribute in the copies table, with the primary key of the book table. Next, unique constraints ensures that the value in a specified column or columns are unique across the entire table. Unlike primary key, a unique constraint allows null values. Unique constraints ensure that all the values in a column are distinct, preventing duplicate and redundant data. They can be applied to more than one column in a table, creating composite unique constraints. Unique constraints automatically create indexes on the column, which can enhance query performance. Now, in the employee table, the email ID is a unique constraint as it can be null, as well as each of the person will have a unique email ID. Each and every employee will have their own unique email ID, and it can be null as well, not like the primary key. Check constraint specifies a condition that must be satisfied for the data to be entered in a table. So the check constraint defines rules that the data must satisfy at the column level. Any data not meeting these conditions will be rejected, and it ensures that the values in the column meet a particular specific criteria. Now, for example, if we take the product ID and price in the product table, and if we give the condition check price greater than 500, then all the values that will be entered under the price column will be only entered above 500, and only those values will be taken into considerations, and any value whose price is below 500 will be rejected. So now we have another constraint called as the not null. This ensures the column does not have any null values. It is used to enforce the presence of the data in a specified column. Not null constraints ensure that a column does not contain any null values, maintaining the data consistency in that particular column. They help in guaranteeing that essential information is present when inserting or updating records. Now, in the example, we have taken the employee table in which employee ID and employee name is given. If we give the condition not null before employee ID or employee name, then there will not be any null values present in the column of any one of the attributes before which we have given the not null condition. Now, these are all the different types of constraints that will be used in SQL. Now we have the retrieval queries in SQL. Retrieval queries in SQL are used to extract specific data from database. They allow you to filter, sort, and analyze information, making them a fundamental part of database management. Understanding retrieval queries is crucial for efficiently accessing and utilizing data. These queries are used to obtain specific information from a database, allowing users to filter, sort, and manipulate data based on their requirements. Retrieval queries are fundamental to database management systems as they enable users to access and analyze data stored in tables. Now, we have many different types of retrieval queries, and below the retrieval queries, we have two different types. One is unary and one is binary. Unary, the below three examples or the three queries show the unary queries where only there is only one record used. So first we have the select. This, when we give the condition select to a particular record or a table, then the whole row of the record will be given or will be printed or shown as the output, and it is denoted by the symbol sigma. Next we have the project. In when we give the project condition before any query or any table, then it will print the whole column of the particular table as the output for that particular condition, and it is denoted by pi. And then we have another condition, rename. So in rename, we can, using the rename condition, we can change the name of the whole table or of a particular column or a row in the record, and it is denoted by the symbol row. Now we have another three different retrieval query methods, which these three come under the binary queries, in which there are two tables or records which are involved in these queries. So the Cartesian query or the Cartesian product. In this query method, the data of both the tables will be combined and will be printed. If we consider two different tables, then, and if we give the Cartesian product of the two tables, then the output of this query will be the combination of all the data present in both the tables, as will be shown as the output for that particular condition, and it is denoted by x or the multiplication symbol. And then next we have the union. In this method, we are going to combine the details of only one tuple or one attribute, and all the values in that particular attribute will be written, and it is denoted by the union symbol or u. And then next we have the intersection. In the intersection or intersect query, in this method, the common values, when we give the intersect condition in between any two tables, then or any two attributes, then only the common values in both the tables will be shown as the output, and it is denoted by the inverted U or the intersect symbol. The Cartesian product, union, and the intersect, these three conditions come under the sets. So these are the set conditions for the retrieval queries, and these are all the different retrieval query techniques. Thank you. That's it for today's presentation.